Good Saturday evening to you all. Well, I'm out here in the shop, and that moving vein speaker has to be completely rebuilt. Now, let me give you some close-ups here. I got the cone out. This is that thing that was on the back that spun around. Well, it actually doesn't spin all the way around. This is part of the assembly that's connected to the vein. And as you can see, I had a heck of a time getting this out. The glue wasn't really holding anything, but this speaker, I cleaned it up a little bit, and it's got brown paint on it. Looks pretty good. There's 3 rivets here that are riveted to the chassis, so you can't remove this. And this cone had to be broken away with a screwdriver because the rivets were right in here. You see these little places where the screws would normally go when you mount a speaker in a baffle? In other words, these holes here, which are not used, but these 3 are, well, you can see where I had to tear out on the top there, the top 3 right there. I had to tear out with a screwdriver and pry it out of there. Otherwise, I would have had to drill these rivets out, and it would be a nightmare getting in there with my drill. There's one right there. I got to take out this electrolytic box, which is going to come out and be rebuilt anyways. This is an electrolytic condenser box that says self-healing. I don't know if you can see that, but I'm on macro. You should be able to. So that's the electrolytic. That's not a problem. I can. These are riveted here. I'd have to take that out. But I would have to take that out, and then there's a rivet down in the back here for the speaker. So I figured this can't be fixed. I'm going to have to recone it, but I don't know what I'm going to use for a cone. And I've never done this before. I might have to make something up. This is a job that may be a little too much for me, but this cone is really bad. It's all warped. You can see it's warped and got holes in it and everything else. But this is the thing here that was originally soldered. I guess somebody probably tried to solder it back on. I don't know if this washer, this is not a screw, this seems to be a rivet. It could even be a pop rivet that somebody put in there. And there's like a washer in there. But this thing is pathetic. So this here, you see this here? That's what they call a moving vein, or there's another name for it. Just type in on a Google search, moving vein, V-A-N-E, speaker, and it'll give you a little bit of a description of them, but not very much. Now, I've always called them moving vein speakers. There could be a different name for them, but that's... Years ago, there used to be a guy that was pretty good in electronics, and he worked around with them. He's dead now. And he used to work with those things, and he's the one that told me that's what they're called. But anyways, there's a coil here, and this is some soldering work here. There's a heavy piece of wire here coming down from the top, but this don't seem to be moving. But here is the vein right here. See this? See that piece right there where I'm moving my thumb? When this coil is energized, it's high. Well, I measured it. It's 392 ohms, and I used 2 different ohm meters. I used my Fluke 73. It read 392 ohms. I used my Motorola. It read about 400 ohms, as close as I can read it. So this connects, these 2 wires here connect directly to the screen grid of your 43 output tube and your plate. And across that is a 005 microfarad capacitor. I'll show you in the schematic. All right, now this schematic compliments of one of my viewers. He says this might be similar to what this radio is. It has the same tubes in it, and it is an Air King, and these are the model numbers here. But he's not sure, but this is pretty close. Now there's another Air King schematic down here, but it uses different tubes. This one uses 6E5, which is what is in there for the I tube. This one uses a 6G5 right here. And it uses different tubes in there. So this is not the schematic. There's two schematics, but this is the one, and this is a little larger. So here's my 6D6, here's my 6C6, my 43, the 25Z5, the 6E5 tube. Now, one of the fellows said that this is a M30HG ballast, but it shows two ballasts here. There's only one ballast in here, and normally when you show a half a tube, it'll have a zigzag line on it, but this is two separate ballasts. Is that right? Ballasts? All right, there's showing two ballast tubes in here, but it also shows it on here too. But anyways, there's a lot of changes that are going to have to be made in here. They got, like all the radios, they switch what could be the hot side. Now, these plugs aren't polarized, but the one I'm going to be putting on is polarized. So the damn switch is on the grounded side. Here's the ground. This is a ground symbol. I guess they used that years ago right here. The upside down antenna. That's a ground. It's showing a field coil. A speaker field? Well, if that's the speaker field, what the hell is this? This is what I just showed you here. There's only two wires going to it. You can see them right here. Okay? So there is no speaker field. So this was probably a little different radio, but it gives me an idea. But I traced this out. Right here. This is grounded. So what this is doing now is switching the grounded side. Because if I put a polarized plug on here, this is going to be the grounded side because this is ground. I want the neutral to go to the chassis. So I'm going to have to pull that off and redo them like I do on all my radios and switch the hot side, which is here. There's a 0.1 capacitor going from here to ground. So okay, this is going to be switched over. This is going to be neutral. So it'll be grounded. This will be hot. So it won't matter that this is a 0.1 capacitor from here to ground. All right, we're back again. I had a telephone call interruption in the house. Let's see. All right, I took resistance measurements. If you look at this wiring here from the switch, this goes to one side of the switch. Here's the other side, right here. Wires are going right down to ground, or right onto the chassis, as it shows in the schematic. And the other end of the wire goes to one side of the volume control. This is the volume control and switch combination. So what I got to do is I got to pull that ground off of there, but not off of the volume control, because you need that one side of the volume control grounded. And there's your capacitor for the high side, which all these will be changed out. But I got to get the ground off of the switch, okay, which is right here. We can't have the grounded side switched. That's got to be the neutral's got to go on there. In other words, we'll change the plug and wire. The neutral side will go direct through here, unswitched, and the switch will be moved over to this side. So that's going to take some doing. But this speaker field, which is not on this radio, one side is grounded, okay? That's not a problem, okay? So, but this is not in this radio. The speaker field is not in this radio. So I can kind of disregard this. But this 0.1 is the same. It's a half-wave rectifier. Your both plates are tied together. Your both cathodes are tied together, 25Z5. And here's your electrolytic block right here, which is this. And that's what's inside this thing. I'm also trying to figure out the ballast. That's the bottom of the ballast socket you're looking at. And I tried unsuccessfully to pry these open so I can get this out. I just can't see that. I got the smallest screwdriver I got, and I can move them a little bit, but I can't get the bottom off. So I can measure it, because I can't figure it out through the radio or the problem with this damn schematic on the ballast. They don't give pin numbers on the ballast, and that's the problem with these real old radio schematics. They don't give pin numbers, so you gotta scratch your head and other places.
Boy, does my butt itch.
To figure out what's what. So I wanted to open up the ballast so I can see what I got in it and to see if it's burnt out. I did put an ohm meter on it, and it was open where the line cord was connected, which was right here and here. So that would be pin 1 and 3. As you're counting, you're looking at the tube. Is the key wave facing upward? You're counting this way: 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so pin 1 and pin 3 is where that line cord was with those two yellow crimp connectors. That's where the line cord was. When I put the ohm meter on the ballast of pins 1 and 3, it read open. But I don't know what 1 and 3 is on the ballast. And somebody gave me a link to ballast, and they said it's a the ballast is an M30HG, but I can't find that in the link that one of my viewers, and I can't keep track of who did what. I approved the comments. I'm just so damn busy as a one-armed paper hanger with a bad case of the crabs. I haven't had a chance to answer too many of them. I did answer them, but you know, the ones that give me the links and the information, I have to try to research it, and I couldn't find that number. So they seem to indicate that they seem to think that this is that number, ballast. It would save me from cutting it open, but I can't get this open. If I had good eyesight, I might be able to, but I don't want to force it anymore, because I may not be able to get it back together again. So, anyways, I got to do something with the speaker, and I'm making this video because maybe some of you guys out there may have something I can use for this here, and what I can use for the centerpiece. It doesn't look right. This piece here does not look like it should be that way. I think it's just a bunch of globby solder. The pin must have come off. Now, I'm going to measure this. It's 4 inches from here to here exactly, and 4 3/4 on the outside diameter. 4 inches on the inside, 4 3/4 on the outside. So, maybe, well, I don't have any speakers here in the shop. I used to have a lot of them. But trying to recover a cone out of a speaker is, usually results in disaster. So, if I can replace this, now I have no idea if this this coil is working. I'm reading 392 ohms DC resistance. The plate load resistance for a 43 tube, I think, is 4,500 ohms. So I know that's DC resistance. This seems like a very low DC resistance for a plate load of the audio output tube. But that's all there is on the tube. Now, this could be the wrong speaker, because that's the wrong schematic, I should say. The right speaker for this radio, but the wrong schematic, because it's showing a secondary winding here and a voice coil. Now, a moving vane speaker would only have one coil and a piece of metal, which is here, which vibrates as the current is flowing through the coil and moves the cone. That's how a moving vane speaker works. This is magnetized. This is not showing up on this. Well, made a liar out of me. Maybe it isn't. I might have had a magnetic screwdriver, and that's probably why. Oh yeah, this is magnetized a little bit, very faintly. I thought this was insulation, but it's metal. All right, so anyways, there's only 2 wires coming off of that. This is the antenna wire. Only 2 wires. One's going to the screen grid, which goes right directly to the B+. The other one comes off the plate of the 43 output tube. But I'm only reading DC resistance of 392 ohms, or you say 400 ohms. 400 ohms is not, doesn't sound like a good plate load. Now I know it's impedance, but I would think that this should read several thousand ohms DC resistance, but what do I know? This is my first time working with something like this. So this is how she be. She's riveted in here, and I had to do that, otherwise I'd have to drill this out, and I'd still end up with a mess anyways, because this whole thing has to be replaced. So before I do any capacitor work or anything in this radio, I must get this speaker working. Now, I don't know if this even works, because this is very, very stiff. There's no compliance here whatsoever. I mean, it vibrates, it could vibrate side to side, but that wouldn't make much sense. This is the other end of it. Let me show you the back here. Okay. Now you see how that is? It comes down, it sticks out over here. And there's a little rod, I guess, a tiny wire that comes out and goes to the center of the cone where this thing is. So it must have been soldered to that. Alright, so it's very hard for me to see that, and I'm sure you can't. But I have to take the light off because I can't do two things at once here. That is very rigid, and there's very little movement down here. And no movement in and out like this. Side to side, but not in and out. So, I have only seen one moving vane speaker in my career, such as it is, and that came out of a transistor radio, about a 2-inch in diameter speaker. I used to be able to get these things. I can't remember where I got them from. Fair Radio Sales back in the 60s. Olson Electronics. I have no idea what they were. Brand new. I had 4 or 5 of the things. They used to make little noisemakers out of them because they were high impedance. And you can, put your transistor directly on it. The collector on it. And make little noisemakers. And those cones you could push gently and they would move in and out. This thing is so damn rigid, it does not move in and out. So, this is kind of new territory for me. I don't even know if this speaker will work if I change the cone and resolder in and take this centerpiece out of here somehow, or make another one, and put it into the new cone, get it in here and solder it in from the backside. Alright, it's 9 p.m. Saturday night, and I'm going in the house and finish up what I'm doing inside, get on the computer and so forth, and maybe I can post this video, and maybe somebody will give me some information as to maybe where I can get, well, not necessarily the whole speaker, unless this coil is shorted, because I have a question, as always. Round figures, should this coil be that low, 400 ohms? In other words, 392 to be exact. But let's say, am I supposed to have a 400 ohm load, DC load, on the 43 output tube? There is nothing else. There is no speaker fields or anything else in here. So that schematic is just kind of like a rough, it just gives me a rough idea, and it's similar to a lot of what's in this radio now. But I need to know why this thing is so damn stiff like that, and it seems to be made that way. If it has any sound at all when it works, it must sound horrible. Must be tinny, no compliant, probably will have a sound of a mid-range speaker. Okay, well, thank you very much for watching. I appreciate all the help that I've been getting on this radio. And like I said, I can recap it. That's not going to be too bad of a job. But if I can't get this to go, I may have to drill this out, pull this whole assembly out of here, and put a regular speaker and an output transformer in here. And I really don't want to do that. And I don't have a 4-inch speaker, which is the only thing I can probably get. I used to have a lot of them. And an output transformer. Unless I pull it out of the tape recorder printed circuit that I junked at reel-to-reel. I do have output transformers in there, but they're made to go on a printed circuit board, and I really wouldn't want to use them here. I'd rather have something that's on the speaker itself. But I don't want to do that. I don't want to go that route. Unless I absolutely have to. So any of you guys that did reconing might give me some information. Reconing of moving vane speakers. Thank you very much for watching. Have a good Saturday night and enjoy your rest of your weekend.